We are now going to start looking at geometric sequences, and we are going to consider a few examples thereof, and then look at how do we find the general formula for your geometric sequence, right? So let me just write that down. We're looking at geometric sequences, okay, or series, doesn't really matter at this point in time. A little bit later we're going to differentiate between what we mean by a series and sequence. Okay, but for now let's just look at the patterns that these ones form. Now I want you to be able to compare this with an arithmetic sequence. In an arithmetic sequence, you take one term and you add something. Then you take that term and you add the same thing again. And then you take that term and you again add. So the key operation with an arithmetic sequence is addition, right? Or subtraction, because they're really the same thing. In our case over here, we're going to be looking at geometric sequences, and the operation we are concerned with is multiplication. Right, so I'm just going to put that over there. That's what I mean by that X, multiplication. That's what we are concerned with. So let's look at a few examples, and the golden rule whenever you get sequences, in the questions they won't tell you every sequence is geometric or this sequence is arithmetic. You're going to have to figure that out. And so it's very important for you to know what makes a sequence either geometric or arithmetic or quadratic. In this case, always the golden rule is to test the sequence. I'm going to use simple examples. Okay, this is a fairly trivial geometric sequence, right? I could ask you to give me immediately a general formula for this, and because you're so good at it, you'd probably be able to give me the general formula. So let's just go over the terminology once again. I'm going to say this is T1, this is T2, this is T3, right? T1 has the value of 3, T2 has the value of 9, T3 has the value of 27, and this corresponds to n equals 1, which means it's in position number 1. This is in position number 2, this is in position number 3, and so forth. Right, so I'm not going to worry too much with that, I'm just mentioning it for interest's sake. Now clearly, if you want to test this sequence and you say, what is the difference between 9 and 3? Well, if I check the difference over there, that's going to be 6, and if I check the difference over here, that's going to be 18, I think. Yeah, that's going to be 18. But if I check the difference over here, that's 6. So clearly this is not arithmetic, right? Because you add 6 here and you add 18 over there. At that point, that's really not arithmetic. So I'm going to take that out. Okay. So it's not an arithmetic sequence. But if I see, how do I go from 3 to 9 and 9 to 27? Oh my word, I'm multiplying by 3 over there, and I'm multiplying by 3 over there. Now, when you multiply by the same term each time, this 3 and this 3, this thing over here is known as the constant ratio. Not constraint, constant. Known as the constant ratio. And that's really what makes a sequence geometric. Let's take another one. Let's do an easy one. Let's say the sequence is 2, and then let's say the next sequence is going to be, the next one's going to be 6. Well, let's make it 8, and then 32. Oh my word, what's happening over here? Clearly I'm not adding the same thing each time. Let me see if I'm multiplying by something each time. Let's investigate that. And when I investigate it, I see, oh, 2 times 4 gives me 8, and 8 times 4 gives me 32. And so again, I find that I have this constant ratio over here. Okay. Now when I see that I have this constant ratio, immediately I know once again the sequence is what we call geometric. 2 times 4, 8 times 4, I'm multiplying by the same thing each time. So let's look at a few more examples, right? Let's take a sequence 5, 10, 20. Can you tell me what are we multiplying with each time? Well, over there I'm multiplying by 2, and over there I'm multiplying by 2 once again. Again, I've got a constant ratio. And the constant ratio that we speak about here is really just 2. Okay, so that's very good. Let's try something else. Let's take a half, quarter, and 1/8. Oh my word, what's happening now? Well, it's quite simple. To get from a quarter to a half, you just multiply by a half. And to get from a quarter to 1/8, you again just multiply by a half. So what we've done in each of these examples is we've we've investigated this through inspection. We just looked at 3 and we looked at 9 and we looked at 27 and we said, oh my word, what are you multiplying by to get there? What are you multiplying by to get there? Or what are you subtracting or adding? When we found that adding or subtracting doesn't work, we said, let's see what you multiply by. Okay? Same thing over here. These things are considered your constant ratios because you're multiplying by 2 and you're multiplying by 2, and similarly over here you're multiplying by a half and here you're multiplying by a half, and again that gives me the constant ratio. Okay, and so when you see you multiply by the same thing each time, that gives you what we call a geometric sequence.